9.2, estimating a population mean. All right, so again, we want to look at the point estimate. We talked about that previously. That's what estimates the value of a parameter. So in this case, we're looking at x bar is the sample mean, and that's going to be our point estimate for the population mean, okay, for those. And so we can look here. We have our fuel economy here for some Toyota Camrys, 2014 pieces, okay? And so we could find our sample mean with those. Now we could also go into our 1vars, put all those values there into our table, and we would get those just as they are. Okay, so we would still come up with our x bar being 28.1, remembering to go into our 1vars on that. Okay, so our point estimate from U is 28.1. Okay. All right, so t distribution. So suppose a simple random sample of size n is taken from a population that follows normal distribution. Our t distribution follows students' t distribution with n minus 1 degrees of freedom, where x bar is our sample mean and s is the standard deviation, okay, for those. All right, now, when you're looking at comparing your z versus your t, you'll notice the big difference there is sigma versus s on those. Now, sigma is our population standard deviation. S is our sample standard deviation. So those will differ for those pieces, okay? And so as we calculate those things and look at them, we can see here that our graphs are a little bit different when we're even using the same size on those pieces. So our first one looks normal, but when you look at our second one, it has much longer tails to it for those pieces. And so that creates a little bit of different piece, okay? And then so that has some different spread to it on those pieces, okay? And even if we increased our size to 10, we still have that piece. It looks somewhat normal, but it's not quite there because the length of the tails on those second part there. Okay, and so again, that deals with the spread, so t is more dispersed. Okay. All right, so the spread of distribution of t as it decreases as the sample size increases on those. Okay, so we want to be able to look for those. All right, so properties of t distribution. It is different for different degrees of freedom, so we have to pay attention to our sample size. It is still centered at 0 and symmetric at 0. The area of the curve is still 1, and each half, it's equal to a half there with those. Okay. Now, as t increases or decreases, they approach 0 but never equal it, just as kind of normal. Now, the area in the tails of the t distribution is a little greater than the area of the tails in the standard distribution, normal distribution. And that's again because we're using s instead of sigma. Okay. As the sample size increases, the density curve of t gets closer to the standard normal density curve. Okay, so it's going to get closer to normal as n increases. And this results in the law because of the law of large numbers. Right. So again, here we're looking at normal. So as we see here, as we increase n on those pieces, the orange line and the red line compared to the purple, it gets closer and closer to normal with those. Okay. All right, so how to determine some t values here with those. So our t value is to the right of t sub alpha. Okay, so that's the area there under those pieces. Okay, so we're going to be looking to the right in these cases. All right, so our t value here, we're looking at t value of 0.10, assuming 15 degrees of freedom. So this is where our tables come into play. So if you go back into Canvas here and you were to scroll down the home page, so let's go back to the home page for just a moment, as fast as the internet will let us. And we scroll down. You'll see here between Unit 3 and Unit 4, we have all of our tables, and we're looking at the T table now. So when we click on it, we'll be able to see the T table. All right, now I'm going to scroll down to be able to see. So you'll notice here that it describes the area in right tail for those. So make sure you're paying attention to that when you're doing stuff. This is all right tail area on those. Now, we wanted to know where T of 0.10 and with degrees of freedom, so DF means degrees of freedom. This is all of those. So that's 15. All right. Now, where do those two things match up? Here and here. And so we get 1.341 for those. Okay. And so that's what we would find there on those pieces. Now, if we needed to the left, we would do 1 minus those things. Okay. And so, but we're going to be doing area to the right for all of those. Okay. Let me clear that off. All right, so with 15 degrees of freedom. All right, so now we continue there. And so we're just kind of looking at the graph, but again, they show here on the table how to do those exact same things with that. And so we would say that the area under the t distribution to the right of t equals 1.341 with 15 degrees of freedom is 0.1. So we would be finding that t value. Okay. Now, if we were to go back and compare that to the z value with those, that z value is smaller. All right, now what about constructing a confidence interval for this? Okay, so we look at our sample data. It has to be provided or some information there. Again, our sample size has to be relatively small compared to the population, meaning less than 5% with those. Okay, and so then we would have our lower bound and upper bound. So these follow very similar to what we've looked at before on those pieces, but we're going to look at how the calculator will do that for us. Okay. All right, and then our margin of error again is kind of that second piece of the upper and lower bounds for those. Okay. All right. So we're just going to go through and look at how the calculator will do this for us. We don't need all these extra pieces here, so I'm going to kind of click through it. All right, so here, now they kind of got their tables. I'm going to go ahead and do this table in the calculator, and then I'm going to switch back and do what was supposed to be put in right there, which was table 2 that we looked at the very beginning on those, okay? And we'll use some information from those pieces, all right? Okay, so here, they want a 95% confidence interval for this table of values. And so we're actually looking at prices down here instead of fuel economy, but we're going to go ahead and do those, okay? So we can see a couple of different ways that we can approach this. Now, because they gave us the data, we want to work with that data. So in order to work with that data, we first want to put that data in. So we would go to Stat and then Edit. And in L1, we would put all of that data, which I've already done for us here. So we plug in all that data here, and we could work through those, okay? All right, so once we've done that, we're going to quit, second mode there to quit. And now we're going to go back into Stat, and we're going to move over to Tests. So this is kind of the new piece to this. Let me try to write this down here. So we go into Stat, and we move over to Tests, okay? And now we want to go down to T interval. Okay, so T interval, which looks like number 8 on mine. So T interval. Okay. All right, now we have data, so we want to make sure that data is highlighted. You can see there that if I move over, the data is still highlighted. If it's not, we'll highlight it and press enter, and that's going to highlight that one. Okay. If we select stats, it's going to change everything, and we're not ready to do that yet. So we're going to go to data and press enter. L1 is where our list is. There's a frequency of 1. Now we wanted 95%, so 0.95. And then we want to calculate. So our confidence interval is going to be here between 38,351 and 41,674 for that. Okay, so our lower and our upper bound for those. And we also have our X bar, we have our S there, and we could use those things for us. Okay, now if we needed the error on those, we could subtract off again. We could take our 41,674 and subtract off the X bar there, 40,012, and get our answer for that piece. Okay, so we can use all those. All right. Now, they don't actually work that problem. They go back and work the original one, so they just made a mistake here, so our numbers are not going to show up on those, okay? But I do want to look at theirs here, and so they determine some other things. So if we're doing by hand here, they've already determined. So some of your problems are going to give you a data table. Some of your problems are going to give you the information, X bar and S. And so if they give me X bar and S, we're going to go into stat. We don't have to worry about putting anything in, and we can still go down to the T interval. Now this time, because they've given me X bar and S, I can put those in, okay? So X bar here, so I've gone over to stats and selected enter. Now, X bar, they're saying is 28.1. S is 2.38. And then we had, I believe, 16, they said. Okay, so let's check there. Yes, N is 16. We can see that here in step 3. And we still want a 95% confidence interval. So now we calculate. Okay, and so we can see that our lower bound matches now, 26.83. And our upper bound is 29.37. Okay, and so that means that we're 95% confident that the mean miles per gallon is between those two numbers. All right. Now they showed how to do it here in Minitab, but we did it just now in the calculator. So based on what they give us, if they give me the statistics X bar and S, we can do it under stats piece. If they give us a table, we just need to fill in L1 before we go. Okay. All right, now, what about finding our sample size? We need to determine what N is to get a specific margin of error for those. All right, and so that's going to be this formula here. Okay, so we have N times, now we notice that's Z, not T, of alpha over 2 times S divided by E all squared. Okay? All right, so how large a sample is required to get within 0.5 miles per gallon with a 95% confidence? Okay? All right, so 95% confidence, now that is our Z. So if we go back to our tables, but I need my Z table, and that was the previous table. We could go back to the home and select it though. For our pieces, so make sure we go to the Z table here. We'll eventually get there. I'm on computer. All right, there we go. We go down to the bottom. So 95% is 1.96. So that's where the 1.96 came from. Now S, we calculated a moment ago in the previous problem. That would be given to you in your problem, which is 2.38. And then it said within 0.5 miles per gallon. So that is our margin of error here, and then we square that. So we put all that in our calculator, we get 87.4 with that. Now again, we always round up on that, so we need a sample size of 88 in order to get this 95% confidence interval. Okay. All right, so those are the things that we're going to need here for 9.2.